infinite, then the series is divergent. So this is the another most important method of the convergence of series. Okay, so we quickly move to the next series, the P series test. We can prove this test by using the integral test, and otherwise we can directly solve some example using the P series test. So P series test is most important test, because when we going to solve the example mainly from the comparison test, then we need to use the P series test as well. So first we are going to look at the P series test. The P series test, sigma n is equal to 1 to infinite 1 upon n raised to p is convergent if p is greater than 1, and this series 1 upon sigma 1 upon n raised to p is divergent if p is less than or equal to 1. So we just need to find the value of p if the given series is in this format, sigma 1 upon n raised to something. Then if the p is greater than 1, then the given series is convergent, otherwise is divergent. And we will take the example of P series test with the comparison test. So I am quickly moving to the next test, is the comparison test. Comparison test have two kind of statement, the direct comparison test and the limit comparison test. So this is the statement of direct comparison test. If the sigma an and sigma bn are series with positive terms, and if sigma bn is convergent and an less than or equal to bn for all n, that means if an less than or equal to bn and sigma bn is convergent, then sigma an is also convergent by direct comparison. Okay, in the same way we can state another statement, that if sigma bn is divergent and an greater or equal to bn for all n, then sigma an is also divergent, okay, by direct comparison. So this is the very straightforward test for the direct comparison, but more importantly the limit comparison test is more important than this test. So I am quickly moving to the limit comparison test. The limit comparison test says that suppose that sigma an and sigma bn are series with positive terms, and if limit n tends to infinite an upon bn is equal to c, where c is a finite and non-zero number, then both series converges or diverges together. So this statement is very important. It says that if we find the limit of limit n tends to infinite an upon bn, and the limit of this portion, if the limit is finite and non-zero, then we can say that both the series sigma an and sigma bn converges or diverges together. So we can use this method, and after using this method we need to use the another method which I have already told you, that the P series test, to solve the whole example, because this test just tell us that the both series converges or diverges, but we cannot decide that the series is convergent or divergent. So to decide the convergence or divergence we need to use the another method, but this test do some work for us to decide the both series are convergent or divergent. Okay, so this is the limit comparison test, and let us look at some examples related to limit comparison test and P series test. Let's one example, that this is also for the check the convergence of sigma n is equal to 1 to infinite 2n square plus 3n upon 5 plus n raised to phi. This example asked in GTU December 2008. Okay, so here it is clear that here an is equal to 2n square plus 3n upon 5 plus n raised to 5. So to use the limit comparison test, we just need to clear before we start the example that what we are going to do. Here an is given and we need to find the bn, using which we can find the limit n tends to infinite an upon bn, and which must be finite and non-zero. So first I to clear this one, and then I taking n square here, so 2 plus 3 by n here, and upon, if I take n raised to 5 common, then 5 upon n raised to 5 plus 1 here. So it is equal to 1 upon n cube 2 plus 3 by n upon 5 upon n raised to 5 plus 1. I have do this kind of work because the bracket part, this part, if I take the limit n tends to infinite, then this part becomes 0, this part becomes 0. So we will get the answer 2 plus 0 upon 0 plus 1 is equal to 2, which is finite and non-zero. We need to remove this part from this expression. So we will take the bn is equal to 1 upon n cube, and after this we take sigma limit n tends to infinite an upon bn. So this part will be removed, and the limit of n tends to infinite an upon bn will be equal to only limit of this part, which is equal to 2. So now let bn is equal to 1 upon n cube, then limit n tends to infinite n upon bn is equal to limit n tends to infinite 2 plus 3 upon n upon 5 upon n raised to 5 plus 1, because in the an part there is 1 upon n cube, and bn is also equal to 1 upon n cube. So when we take limit n tends to infinite n upon bn, then the 1 upon n cube remove from the both part, and we just remain the part is limit n tends to infinite 2 plus 3 by n upon 5 raised to n raised to 5 plus 1, and which is as our planning. This part will be equal to 2 plus 0 upon 0 plus 1 is equal to 2, and which is finite and non-zero. Okay, so by comparison test, sigma n and sigma bn converges or diverges together, right? So in this way we can decide that here sigma n and sigma bn both converges or diverges together, but still we haven't decided that both series are convergent or divergent. So this method this method says that the both are convergent or both are divergent, and from the bn we can say that here sigma bn is equal to sigma 1 upon n cube. This is the here is convergent, right? Why convergent? Because this is the P series test, 1 upon n raised to P. This is our P and P is equal to 3. So we can say that this series is convergent as P is equal to 3, which is greater than 1. I have used here P series test. The given series is convergent. Which series? Bn is convergent, and we have already said that sigma n and sigma bn convergent or divergent together. So here sigma bn is convergent, so directly sigma n is convergent. So to solve this example we have used two methods. First we have used the limit comparison test, and after that we have used the P series test, and then we have decided that sigma n is convergent as sigma bn is equal to 1 upon n cube is convergent, so sigma n is also convergent. So this is the most important and related to this method frequently example asked in the GTU's exam. So this is most important topic. Let us look at one more example related to comparison test and P series test. Okay, so let us look at the one more example. Take the convergence of sigma n is equal to 1 to infinite n plus 1 upon n raised to P. Okay, so here an is equal to n plus 1 upon n raised to P, and if we take n common here, so n 1 plus 1 by n upon n raised to P, which is equal to 1 plus 1 by n upon n raised to P minus 1. So first we need to plan that what is our Bn. Here if we take the limit of this part, then 1 limit n tends to infinite, then 1 plus 1 upon n is equal to 0. This part becomes 0. So 1 plus 0 is equal to 1, but we need to remove this part n raised to P minus from this expression. So we will take let Bn is equal to 1 upon n raised to P minus 1, and then limit n tends to infinite n upon Bn is equal to 1 limit n tends to infinite 1 plus 1 upon n, because here this part n raised to P minus 1 here, n raised to P minus 1 here. When we take an upon Bn, this part will be cancelled, and the rest of the part is 1 plus 1 upon n. So limit n tends to infinite an upon Bn is equal to 1 plus 1 upon n, which is equal to 1 plus 0 is equal to 1. N is finite and non-zero. Okay, this part is finite and non-zero. So as we discussed in the previous example, this series is sigma n and sigma bn both converges or diverges together. Okay, so now we just need to decide that both series are convergent or divergent. Here we can say that sigma bn is equal to sigma 1 upon n raised to P minus 1. Okay, so if we look at the paper, then sigma bn is equal to sigma 1 upon n raised to P minus 1, and this series sigma bn is convergent if p minus 1 is greater than 1. Okay, that means p greater than 2. So this series is sigma bn is convergent if p minus, because here the index of n is p minus 1. So this series is convergent if this index is greater than 1. So p minus 1 is greater than 1, then the series is convergent. That means p greater than 2, then the series is convergent. And divergent if p minus 1 is less than or equal to 1. That means p less than or equal to 2. So the given series is convergent if p minus 1 is less than or equal to 1, and the given series is divergent if p less than or equal to 2. And we have already said that sigma n and sigma bn convergent or divergent together. So from this we can say that sigma an is convergent if p greater than 2, and sigma n is divergent if p less than or equal to 2. So in this way we can solve the examples of infinite series to check the convergence or divergence of the series using comparison test and p series test both. So this is most important method to check the convergence of the series. So in this method, if we look at the PPT, then in this method we will take first the limit comparison test, and we will check limit n tends to infinite, n upon bn is finite and non-zero. Then we will say that the given series is sigma n and sigma bn, both series are convergent or divergent.